All right. I'm going to go through the rest of the word problems just in case you wanted to watch this. See a couple more examples. So, on slide 11, number 5, you go to a garage sale and the items cost $1 or $5. So that is a distinguishing thing. We have some items that cost $1 and we have some items that cost $5. That's going to be important. You spend $42 on your purchase. So just like that previous problem, there's something that deals with money. And then for 18 items, this is actually a second thing to think about. You have an equation that's going to deal with how many items you bought, and then an equation that deals with how much money you spent. How many of each type of item did you purchase? That question right there is always good to help you define your variables. So I'm going to call them X and Y. We're going to say X is the item that costs, well, I guess it's the number of items that cost. We'll say those are the dollar ones, so X will be the cheap ones, and then Y is going to end up being the number of items that cost 5. So one of our equations deals with the number of items, and one of our equations deals with money. And as I said on the previous problem in class, the money one is the one people normally get. For the money one, every time you buy an X item, it costs $1. Every time you buy a Y item, it costs $5. And in total, well, I'm writing this in the wrong color. Oopsie. I want to do the money in blue. Every time you buy an X item, it's $1. Every time you buy a Y item, it's $5. And you spend overall $42. So there was our money equation. Now we need the other equation that deals with how many items did we actually end up purchasing. You can either buy an X item which costs $1, or you can buy a Y item that costs $5. So you buy X or you buy Y, and no matter which one you buy, you're buying 18 in total. So your X and your Y have to add up to 18. We're not dealing with money. You have X items, you have Y items, and you buy 18 of them total. So if you bought 10 X items, you would have 8 Y items. This system looks to me like substitution is the way. Excuse me, not substitution, elimination. I am off my game right now. X plus Y equals 18. X plus 5Y equals 42. I would do elimination. Even though we don't see opposites, it'd be pretty quick to make opposites happen. If you multiply either equation by -1 to change the signs, I'm going to do the top just because. You could do the bottom. We get -X minus Y equals -18. We get X plus 5Y equals 42. Now, if you look in front of X, you will see that we have opposite variables. We are ready to go on elimination. So elimination, we add together. -X plus X is 0. -Y plus 5Y is 4Y. She is doing her best to ruin my video. 4y, -18 plus 42 is 32 minus 8 is 24. From here we divide by 4, y equals 6. Go back to one of the original equations. I'll just choose the x plus y equals 18. We'll replace y with 6. We'll subtract 6 from both sides, x equals 12. So our answer is we bought 12 $1 items and 6 $5 items. Okay, on to the next page. Suppose you start an ice cream business. You buy a freezer for $200. It costs 45 cents to make a single scoop ice cream cone. You sell each cone for $1.25. How many cones do you need to sell to break even? So this one is quite a challenge. We have to think about all these different things. You bought a freezer for $200 and it costs you 45 cents to make an ice cream cone. You sell an ice cream cone for $1.25. How many cones do you need to sell to break even? Man, oh man. So what do we do for this one? Well, let's start by highlighting. Freezer costs $200. That's going to be something. It costs you 45 cents to make an ice cream cone, but you sell those cones for $1.25. Break even. What does break even mean? It means that you're not going to be losing any money. So let's try to think about our equations in how much you make and how much you've spent. So we have to kind of think about these as two separate things. Let's think about how much money we're spending and how much money we're selling things for. So let's just say Y is like our money. Let's call it our expenses or our sales, whatever. Let's talk about how much we sell cones for. Y equals, let's call X a number of ice cream cones, because that's what we're selling. That's what's going to make us our money. So we sell an ice cream cone for $1.25. So our amount of money we get from sales will be 1.25 times however many ice cream cones we sell. Now our expenses, it costs 45 cents per ice cream cone to make them, and we also have already spent $200. Kind of $200 in the hole. So that equation kind of makes up how much money we've spent. And these are actually our two equations. So this is our sales equation, this is our expenses equation. And we're ready to solve. This one looks like it is ready for substitution. And why would I say substitution? We have variables by themselves. Y is all by itself. So I'm going to replace Y in the other equation. Sorry about the yellow. It's not the color I meant that to be. Meant that to be blue. So we're replacing Y, this Y right here, with what Y is equal to, 1.25x. Now we have an equation which, while a little challenging to solve, is something that we've actually done a handful of times. We're going to subtract 0.45x from both sides. 1.25x minus 0.45x, let's see, is oops, it's writing in the wrong spot. 0.8x equals 200. We can divide by 0.8. This might be a good calculator part. Type that in a calculator, we get x equals 250. So we have to sell 250 ice cream cones for our sales to be equal to our expenses, for Y to be 0. 250 ice cream cones is where we start making money after we sell. Okay, let's move on to a question that's more like something I would ask you. Number 6. a little bit challenging. You have 21 coins, all dimes and nickels. So you got to know what a dime and a nickel is. The total value currently that you have is $1.70. How many nickels and dimes do you have? If you remember when we started systems, you had a problem, or I had a problem like this that I kind of talked about. So now we just have to set it up ourselves. So we need to define our variables. What do we have? We have nickels and dimes. So n will be number of nickels. D will be number of dimes. And then we have two things going on. We have 21 coins and we have a value of $1.70. So we're going to make two equations. One equation deals with having 21 coins. If we had one nickel, we'd have 20 dimes. If we had two nickels, we'd have 19 dimes. So every time we have our nickels, we add that to our dimes and it needs to total to 21. That's going to match our red equation. Our total value is $1.70. Here's where you got to know how much money both of these are worth. A nickel is worth 0.05 cents. Be careful with that. And a dime is worth 0.10 cents. Sometimes people put 5 and 10 and then at 1.7. That's not going to work. If you're going to do 1.7, you got to do it in change. So it's 0.05 and 0.1. Now we set this up. N plus D equals 21, 0.05 N plus 0.10 D equals 1.7. I think I'm going to do elimination. I like elimination. I think I'm going to do elimination. So I'm going to multiply the top equation by one of the numbers in front of D or N to make them match, but I'll do it negative-wise. So maybe I'll do times negative 0.05. Maybe I'll do that. So we get negative 0.05 N. Maybe I shouldn't write plus minus. Maybe I should write minus 0.05 D equals, and again, this is a good calculator question. I don't know what this is off the top of my head. Negative 1.05. Then we take our other equation, which we don't have to multiply anything to. That's nice. 0. Come on. It's not writing very well for me. 0.10 D equals 1.7. Now we got opposites in front of N. Those are opposites, so we're ready to add our equations together. Those are opposites. When we add them, it'll be 0. Negative 0.05 D plus 0.1 D is 0.05 D. That equals negative 1.05 plus 1.70 is 0.65. We divide both sides by 0.05 and we get D equals 13. So there will be 13 dimes. Plug it back into one of the equations. I'm going to choose the first one. That's easier. N plus D equals 21. N plus 13 equals 21 because we replaced D with 13. N equals 8, so we have 8 nickels and 13 dimes. 2 more. The sum of two numbers is 27. The larger number is 3 more than the smaller number. Another tricky one. This one's kind of like that boys and girls choir problem. So the sum of two numbers is 27. I guess we need to define our variables first. Let's say x is one number, y will be the other. So if their sum is 27, that is x plus y equals 27. The larger number is 3 more than the smaller number. The larger number is, let's just say x is the larger number. The word is, we can think about that as an equal sign. 3 more than the smaller. We take our smaller number, we add 3. Those are our two equations. X plus y equals 27 and x equals y plus 3. This one looks ready for substitution. Why substitution? In my mind, this x is by itself. So we're going to replace x in the other equation with what it is equal to. So I'm going to take that first equation. What am I substituting in for x? Well, x is equal to y plus 3. So I'm going to plug in y plus 3. Going through and solving, this y and this y are on the same side, so we're going to combine like terms. 2y plus 3 equals 27. We're going to subtract 3 from both sides. We get 2y equals 24. Divide by 2y equals 12. Go back up to one of your equations. I'll just choose the second. X equals y plus 3. X equals, we'll substitute in 12. X equals 17. 15. Sorry. So one number is 15. One number is 12. Their sum is 27. The larger number is 3 more than the smaller. 15 is 3 more than 12. All right, our last example. You are buying your friend's lunch for helping you paint your house. You buy a total of 12 sandwiches, and you spent a total of $36.40. So as we've seen through some of these problems, we kind of have two things going on here. We have an amount that you purchased, and you have a cost associated with that. If you only bought turkey sandwiches, which are $3.20 each, and tuna sandwiches for $2.80, how many of each did you purchase? So we have to define our variables. Let's say T will be the number of turkey sandwiches. Ooh, tuna also starts with T. Maybe we'll use E. No, U is still kind of confusing. N? Yeah. You know what? I'm gonna go with F for fish, even though I realize that the letter F isn't in tuna. So this is why it's important to define your variables. Don't call them both T. They're different. We have one equation where you bought 12 total sandwiches. That is T plus F. You take both of those numbers. They have to add up to 12 because you bought 12 sandwiches. And then you deal with the money equation. So a turkey sandwich costs $3.20, so we're going to put $3.20 in front of T. Tuna costs $2.80, we're going to put $2.80 in front of F, and that's going to be equal to our cost, which is 36.40. So we have our kind of count equation and our money equation. Again, I think this looks good for elimination. I'm going to multiply the top equation by... what would be best? I'll just multiply it by negative 2.8. So we get negative 2.80 T minus 2.80 F equals, I don't know what negative 2.8 times 12 is, so I'm going to go to my calculator. Negative 33.60. We don't need to do anything to our other equation because we have opposites by just multiplying by one of them. So we're ready to add because if you look in front of T now, those are opposites. Or F, I said T, sorry. Adding them together, we get point, I want to be writing in black. Negative 2.8 T plus 3.2 T is 0.4 T. Negative 33.60 plus 36.40 is 2.80. We're going to divide by 0.4. And we get T equals 7. I'm going to use the T plus F equals 12 equation. 7 plus F equals 12. F will equal 5 because we have to subtract 7 from both sides. So we bought 7 turkey sandwiches and we bought 5 tuna sandwiches. Okay. Besides that break-even question, I'm hoping that these examples are helpful. You definitely don't need to watch this. I mean, you just did. But if you were having trouble, I'm hoping that some of these extra examples helped you out in setting up your systems.